Hey everybody, welcome back to Math 30-2. Today we are moving on to the third lesson in sinusoidal functions, and that's graphing sinusoidal equations. If you've looked at lesson 2 already, you remember that we have a form of our sinusoidal function here where each of the parameters A, B, we didn't talk too much about C, but that's okay, and D are representative of certain characteristics of a sinusoidal function, where A, if we take the absolute value of A, that gives us the amplitude. And we know that if we know the maximum and minimum of a sinusoidal function, and just to remind us that that maximum and minimum comes from the y-coordinate of these maximum points. So we are looking for what is the y-max, and the other part of that is the y-min. So that's what that max and min refers to. The other thing that we learned about was the period, and we discovered that the period equals 2 pi over the b value of the equation. And we also figured out that if we can switch these around to determine the b value from the period. And we also figured out that the median value, which is like an average value, can be determined kind of like when we have two test scores that we want to find the average of. We take the two test scores, add them together, and then divide by 2 to give us the average. Same thing goes for the median. We take the max y, the min y, and divide by 2. Now today we're going to be doing a lot more graphing, and we want to make sure when we're graphing sinusoidal functions that we are putting our calculator into radian mode. So on our calculator, to find the radian mode, we go into the mode button right here. After clearing the calculator, it generally defaults to radians, okay? Not generally, it does. And sometimes we might be working in degrees. So if we're doing something where we're working in degrees and then coming back to radians, we have to make sure when we're graphing these things, it's always in radians, or we might end up with some answers that are a little off. So let's get started and go ahead and look at this first example. Although it says number 2, it's number 1. And this is a question where it says the mean daily maximum temperature at Comacook Beach in the Yukon are represented by the formula T equals 17.11 sine of 0.52 m minus 2.83 minus 5.38, where T is the temperature in Celsius and M is the number of the month of the year. And as you can imagine, mean daily temperatures are going to fluctuate. And because they fluctuate in a cycle from year to year, that's why we get that sinusoidal function. So let's get started by determining from the equation what is the maximum and minimum temperatures. Now remember, calculate means we need to show some work. So let's go ahead and find the maximum values. Well, the maximum value, and I didn't point out a little bit above here, comes from our A plus D. Now, I like to think of it as D plus A because when I'm looking here, if this is my D, I'm going to add A to it. Or if this is my D, I'm going to subtract A to get to the min. So I tend to think of it this way a little bit, but whichever way makes sense to you. So let's look at the max. The max we're going to say is D plus A. And the D value on our equation here is minus 5.38. So in other words, the max is minus 5.38 plus A, which is 17.11. And we're going to put that in our calculator. And that's going to give us 11.73. Now that's in degrees Celsius because this is a temperature. So that's our maximum temperature. The minimum temperature, min, is D minus the A. So we have minus 5.38 minus the A, and putting that into the calculator, we get minus 22.49 degrees Celsius. Let's look at B. What is the domain? Well, if we're talking about the first month of the year to the last month of the year, our domain is going to be M such that 0 is less than or equal to M, less than or equal to 12. M is an element of the real numbers. Now the range, which is our T, is T such that we're going to go with that minimum value now, which is negative 22.49 degrees Celsius. Now let's not put in our units in this part. And T less than or equal to 11.73. And temperature is also continuous. Therefore, we're going to have T is an element of the real numbers. Now let's calculate the period for C. Calculating the period, we need to know the B value, and the B value is 0.52. So the period is going to equal to 2 pi over 0.52. Now we can put this in our calculator to give a decimal value, and when we do that, we get 12 decimal 0.830. Now, it doesn't say what to round this to. Let's round it to the nearest tenth. So I'm going to say this is equal to 12.1. Now, that is months as our unit. So the period is just a little over 12.1 months. Next question. What is the average temperature? Oh, there's that word average again. So to find the average temperature, we're going to find the median value or the D value. Well, that one we don't even have to look at anything other than the D value on the equation. No calculation necessary. So the average temperature is negative 5.38 degrees Celsius. And the last two here, amplitude. What is the amplitude of the graph? Well, the amplitude is equal to the absolute value of the A. And in this case, our A value is 17.11, and it's also a degree Celsius. And it's asking us to determine what is the temperature during March. Okay, well, March is the third month, so that's when M equals 3. So we can put this in our calculator. Let's do that. We're going to say T equals 17.11 times 0.52 times 3, and I forgot the last part, minus 2.83. And we're going to put all of this in brackets. I'm going to show you how to put this in the calculator because we need to make sure everything is bracketed correctly. So when we're doing something like this in an exam, You need to show the substitution of m here. So you do need to write this out and show the person where the m is going. Now, the next thing we're going to do is put that in the calculator. And when we do that, we want to make sure that things are bracketed off correctly. So we can go 17. Oh, I forgot my sign. Sign goes in there. 17.11 sine. Now, we have to multiply these two things together. So we can put those in brackets. We don't have to, though, because order of operation would mean this times this, subtract that. Our calculator will do it that way. So it's going to be 0.52 times 3 minus 2.83. Now, here's the important part. We need to close the bracket. If you don't close the bracket, what you're telling the calculator is that minus 5.38 is inside the bracket, and that's part of the sign, which is just not the case. The only thing that the sign is taking is this right here. So then we're going to subtract 5.38, and we get negative 21.72 degrees Celsius. Let's round it to a tenth. So it's negative 21.7 degrees Celsius. So the temperature in March is minus 21.7 degrees Celsius. Kind of cold for March. Let's look at the next question. Now remember, these Ferris wheel questions also can be modeled by a sinusoidal function. And in this case, y represents the height and x represents the time. The first thing it does is asking us to determine the radius of the Ferris wheel. Now remember from the activate section that the radius is equal to the amplitude. So we need to determine the amplitude, but we know that equals the absolute value of A, which is the absolute value of 18, which is 18. So what is the radius? Well, the radius is 18, and we got to make sure we have our units, so it's going to be 18 feet. So that is the radius. It is 18 feet. The next one is, how much time does it take to make one revolution or one cycle? And that is our period. So we need to determine the period, and we know the period equals 2 pi over our b value. Our b value in this case, look at right here, our b value is 2.8. So to find our period, we're going to say 2.2 pi over 2.8. Put that in the calculator, and that is 2.24399. But let's round this one. It doesn't say. Let's round it to the nearest hundredth. Let's just get creative here. So that's 2.24. So how long does it take? It takes 2.24, and the units for time is minutes to make one revolution. Okay, next question. What is the maximum height? Well, remember that the maximum equals the average value d plus the amplitude. Well, our average value D is over here. That's our 21. And we've already determined the amplitude was 18. So our average value D is 21 plus 18. And that gives us 939. And because this is a height, we have to have it in feet. So the maximum height is 39 feet. The next part is, what is the height of the center of the Ferris wheel? Well, remember that center of the Ferris wheel, if we want to draw these things out a little bit, the center right there is going to be whatever the minimum height is, because remember that's the minimum height here, plus the radius, or in other words, the D value, which is in this case already given to us by our formula, which is 21. So the height of the center of the wheel is 21 feet. Got to remember the feet for our units. Last one for 2. In one revolution, at what time or times, look, and they noticed, they're giving us a little hint here, that is the Ferris wheel at a height of 25 feet. So really what we're doing is, this value 25, that's a Y value. So what we're really doing is we're trying to solve this equation right here. And the way we do that is we make one side equal to our y1. We make the other side equal to our 18 cos 2.8 x plus 12 plus 21 on our y. And we're going to use second, trace, and remember that is a 5 for intersect. So let's break out the calculator and put that in. So in this one, let's clear that up. We have y equals, so the y1 we're going to put 25, the y2, 18 cosine. So notice here it puts the bracket in, even though in our question it didn't. So we're just going to keep going, but we're going to continue with the bracketing like the question showed us. So we're going to say x plus 1.2 right here. Now, because it did that, we have to double bracket it up. So we have to match the bracket. So opening bracket has to have a closing bracket. So notice we have 2 opening brackets. So we have to have 2 closing brackets before we put in the 21. So your opening and closing brackets always have to match. Now we have to check our window settings because notice our maximum is 39 feet. So our Y max has to be at least that. Our period has to be 2.24 minutes. So we're okay to go up to 10. That's going to show us a few revolutions if we keep it at 10. But if you want to keep it shorter, you can. If you want to put it to maybe 7, make it a little shorter, you can do that. You can keep the scale at 1. Now, the minimum Y value is the height of the ground, which is 0. And like I said, the maximum is 39. If you wanted to put it a little higher, you can put it up to 45. Maybe change the scale, but going up by 5s in that case. Let's hit the graph button. There's our 25 line. And now look what's going on here. Got a bunch going on here, lots of intervals. And this was with going from, let's see here. Did I put it in right? I feel like I might have put it in wrong. Let me double check. I got 18 times cos. Oh, I put 12. What's going on there? And the reason I knew that this was wrong is because the period was 2.25. And if the period is 2.25 and the distance from here to here is 7, I really only should see 3 cycles, but I saw a bunch here. So that gave me a hint that, I must have put something wrong. And when I go back, sure enough, I don't know why I put 12 there. It's clearly 2.8. So I'm going to go 2. I'm going to insert the 8. There we go. Now let's try it again. There's our 25 line, and there we go. So that makes more sense to me because this one now has that 2.24 period, which, we got 1, 2, 3, just a little over 3 cycles in 7 minutes, which is what we were kind of expecting, not the other way around. So keep those things in mind when you're doing these kinds of graphs, that making little errors can cause things to look funny. And if things look funny to you, go back and check your formula again. So now that we have that, it says times or time in one revolution. So the first revolution starts down at the bottom because that's when you get on, goes all the way up to the max and comes down. So we're looking for this intersection here and this intersection. So we need to find 2 times. So we're going to go second, zoom. Second, trace, my bad. Late at night, doing videos. There we go, 5. Now, remember, we have to go close to where the intersection is. So we're going to go to the first one first. Go enter, enter, enter. And we get when x is, or y is 25, when x is 0.563. Okay, oops, I lost my calculator. Let's do it again. Second, trace. This time we're going to go over to the other one. So 5 for intersect. I'm going to just dodge over to here. Enter, enter, enter. When y is 25, the next one is 1.52. So at what time? The Ferris wheel will be, and it really isn't the Ferris wheel. We really think of this as one of those chairs that we're following. So the Ferris wheel or the chair will be at 25 feet at times, let's round it to 2 decimal places, 0.56 and 1.52 minutes. We got to make sure we have our minutes in there. And there we go. Let's move on to question 3. Now in this one here, it says the tide at a boat dock can be modeled by the equation. And again, tide is one of those cycles in nature. Anything cyclic often can be modeled with a sinusoidal function, and tide is one of them. So it says it can be modeled by this sinusoidal function here, where t is the number of hours past noon and y is the height. Now, I'm not sure if I mentioned this before. Okay. I probably should have if I didn't. Even though we call these things sinusoidal, Sinusoidal functions can be sine or they can be cosine. So you might have noticed that already, that sometimes we're using cosine, sometimes we're using sine, but they're still all part of sinusoidal functions. So let's keep going, and it's asking us to algebraically find the maximum minimum. So in diplomas, in unit exams, we have to really take care with our directing words, and algebraically is a strong directing word that says you got to show the math. So if we want to find the maximum, we know the maximum equals the average value plus the amplitude. And in this case, our average value is the D value, which is 8. Now the amplitude is the absolute value of -2, which in this case, the absolute value of -2 is 2. So we're just going to say the maximum is 8 plus 2, which is 10, which means the minimum is D minus A, which is 8 minus 2, which is 6. Now, in this case, they said that this was in feet. So we're going to say the max is 10 feet and the min is 6 feet. Now, what is the amplitude? Well, we already figured that out. The amplitude is the absolute value of A, which is 2, and it's in feet as well. Okay, let's look at B. What is the period? Well, the period is 2 pi over the B value. And the B value in this case is pi over 6. Now, we're not worried about that because we know when things look like fractions with period, we're going to kiss and flip. So we're going to say 2 pi times 6 over pi. And we know that when one pi is up and one pi is down, we can cancel those out. And then we can say 2 times 6, which is 12. And time or period is in hours. So the period is 12 hours, which kind of makes sense when you think of tide because tide changes a few times a day. So every 12 hours, and that means we get this cycle repeating itself twice in a 24-hour period. So let's go ahead and graph this thing because in the next question, it's asking us how many hours in one period is the tide at least 7 feet. So we're going to start by graphing this and we're going to use the information we have here just to make a graph on this chart. So the first thing I'm going to do is I'm going to put the median line in. I know the median line is at 8. So I'm going to draw the median. I'm going to draw the maximum and the minimum, which was at 6. The other line that I want to draw is where is the first period? Well, it's after 12 hours. So I'm going to draw a line at the 12 hour, and I know it's going to repeat at the 24th hour as well. So really, I am going to have 2 cycles right in here. Let's see, let's pick a color. Let's go green. So if I want to put this one in here, remember, I have to have 1 revolution going, either starting up or down. In this case, it's starting down. You can check this on your calculator and we'll do that in a second, but I just want to do it this way first. So halfway between 0 and 12 is 6. So often when you see this negative here in front of a cosine, that means the minimum is starting at a minimum. But you can always check it in your calculator. But I just want to get kind of the hang of what's going on. So 0 to 12 is 1 revolution. If it starts at a minimum, it has to go up. And at the middle, it's going to hit the max, and then it's going to come down. And then it's going to go up. Now it's going to hit that 18 mark, which is halfway between 12 and 24. And then it's going to go down. So we kind of got this idea right here. So there we go. We can get rid of all our little lines here. The only line I'm going to keep, however, is this one, because I want to bring that down to 7. Because it says when is in a 24 or a 1 period is the tide at least 7. So the word at least means it is 7 or more. Now, I'm going to draw this out over top. This is where it equals 7 here and here. At least means, in this case, let me make it nice and thick so it shows up, is it's going to be, this is at least 7. All of these values are above 7, so at least 7. Now, if I went any further than this line, now I'm below, which means it's no longer at least 7, it's below 7. So this section here and this section here don't count. So what I need to do is I need to figure out what time does it hit 7 right here. And then I need to figure out which time does it come back to 7. And I want to find the time between this time and this time. So once I find them, I'm going to subtract them. And that's going to represent the total time that the height of the tide is above 7 feet. So all through here. So in other words, when I find this point, I'm going to drop this line down to find the corresponding x value. I'm going to drop this line down to find the x value. Our calculator is going to do it, but we can kind of reason it out. So these are going to be well, not x values, these are t values really, because it's time 2 time 1. And we're going to subtract them because that's going to give us the time that it's above 7. So let's go ahead and put this in our calculator. So we're going to go into here. We don't need this part now. We're going to delete this too. And we're going to put -2. Remember, negatives have to be that sign, not the subtraction sign. So -2 close. Now we have our bracket open. If you want, you can double bracket and go second pi divided by 6. Close the bracket. Okay, remember if we have to put an x after that. And we have 2 open brackets, so we have to have 2 closed brackets. And then we're going to add the 8 after we close the bracket. Now the max and the min, let's look at what we have here. This was from our previous question. Our range needs to, our domain, needs to go from at least 0, let's go with 24 hours in a day just to see what it looks like. And we can go up by 2s. The range is going from 6 to 10. So I'm going to leave the bottom at 6 and I'm going to put the top at 15. And then I'm going to make that equal to 2 is fine. Now let's take graph. Okay, there's the first. And there's the second. So we have those 2 there. Now we want to go in, now that we have that, and put our 7 line in. There we go. So what have we done? What we're doing is we're now looking for those 2 intersections. So to find the intersection, it's second trace 5 for intersect. So we need to find T1 and T2. Oops. There we go. So second trace, 5 for intersect. Now we have to go all the way over. So click that a bunch of times. Hit enter, enter, enter. When x equals 2, y equals 7. So the first time, t1, is 2. Let's get the second one. Second trace again, 5 for intersect. This time, we're going to go close to the second intersection that we're interested in. So head on over, hit enter, enter, enter. And now when y equals 7, x equals 10, so that's our t2. So what is the difference between these two times? Because this is hours, so that's at the second hour, and at the 10th hour, our graph was a little off. You can tell that we were a little bit off there. That's okay. It's an estimate. And so to find the time above or greater than or equal to 7, that means we're going to say 10 hours minus 2 hours is 8 hours. So the tide is at least 7 feet for 8 hours. And let's move on. And another Ferris wheel question. You're getting the idea. We like Ferris wheels. So a Ferris wheel has a radius of 8 meters and its center is 10 meters above the ground. A rider gets on the chair of the Ferris wheel at the lowest point and completes one full revolution in 48 seconds. I'm actually going to highlight that too. Determine a function in the form of h equals a sine bt minus 1.57 plus d, where h represents the height of a rider above the ground and t represents the time after the ride has started that could be used to model the height of a rider. So we need to find a, b, and d. Well, we know the a for these Ferris wheel questions, or the amplitude, equals the radius. And the radius, they actually give it to us. It is 8 meters, so it is 8. Now, the center of the Ferris wheel, we've talked about this a few times. Remember that the center of the Ferris wheel represents the average height, or in other words, the distance of the center above the ground, and that's our D value. So the center, which is 10 meters above the ground, means that our D value is 10. They also tell us about one full revolution is 48 seconds. That tells us the period is 48 seconds. Well, what does that tell us about the B value? The B value equals 2 pi over 48. Now we can reduce this and keep it as a fraction and say pi over 24. And we have that there now. So let's fill everything in we know. So the H equals, A value is 8, sine, B value is pi over 24. Now this is in T for time. We don't use X for this one. And 1.57. Now we got to close that bracket just like they do in the question and then add our D value which is 10. And there we go. And if we wanted to graph this thing, we know that it takes 1 full revolution in 48 seconds. So let's put some lines in again for our median, maximum, and minimum values. The D value is at 10, so we got that line there. The maximum, well, the maximum value is going to be our median value, which is 10, plus our amplitude value, which is 8. And if you want to always write it down, that's okay, we can write it down. We can say max equals D plus 8, which is 10, 10 plus 8, and then that equals 18, and that makes our minimum value 10 minus 8, which is 2. So we can sketch those lines at 18 and 2. It takes 48 seconds to make 1 full revolution, so 1 full cycle has to go here. They tell us that the rider gets on at the lowest point. Okay, so that means we're going to be starting right here. We're going to go up, and halfway through the period, we're going to hit our max. And half of the period, half of 48 is 24. And then we're going to finish down at the bottom again for 1 complete cycle at 48. So it's going to come up, hit 24, and then come down. If you want to be super accurate, you can divide 48 into 2, and then you can divide these sections in. And this is just going to help us graph this a little bit more accurately. So now we have the 4 pieces of our graph. I'm going to make it a thicker line so it shows up. So we're going to start at the bottom. Then a quarter of the way, we're going to hit this point. Halfway, we're going to hit this point here and here. So we head on up, head for this point here, start turning towards that maximum. Oops. Head on down to that point right there, getting a little wiggly. And then turn again to get there. So this would represent 1 cycle, 1 full revolution, 1 rotation, however you like to say it. If you start at the bottom of the Ferris wheel, go all the way up to the top, and then all the way back down again. Let's go on to the next question. Now, so far, we've been given a lot of questions that are in context. This one actually is not given a context. In this one, we've been just given some information, and we're being asked to graph this thing here. Couple bits of information is we have a y-intercept at 0 and 1. So let's go ahead and let's use a different color here. And I'm going to circle in a dot at 0 and 1. So when x equals 0, y equals 1. So we know our sinusoidal function has to go through there. The next thing we know is that the period is 120 degrees. Well, that tells me that 1 cycle is going to occur here. So between 0 and 120. That means in this case, every 120, we're going to have another cycle. So between each of these lines is going to be 1 full cycle. The next thing that we're told is the range, and the range has a minimum value of -2, so it's going to not going to go any lower than that line, but it's not going to go any higher than +4, so it's going to go there. So now we have that sorted out. The other thing that we can calculate from that max and minimum is our p-value, the median value. That's going to be the average value, which is the max plus the min divided by 2, which is 4 plus -2, which is our min, which is 2 over, so 4 plus -2 is 2. 2 divided by 2, there we go, we got 1. So notice that that intercept is actually on our median line. So that means we are going to start here, finish here. It has to go to the maximum. So this actually, we're going to split this up into 4 pieces again. We're just going to do one section first. We're going to start by dividing this section up into 4. The reason I like doing this, oops, that's not right, is because of the symmetry of these sinusoidal functions. I can highlight if I'm starting here. There we go. What's going on? Having a little trouble here. Just give me a sec. Problem solved. That means if I start here and I end here, it's going to have to hit in the middle right here because it has to go up to here, down through the midline, all the way back to the minimum before it comes up again. So see how there's 4 sections and they're like mirrors almost of each other. So for instance, from here to here, let's make that thick so it's easier to see. It's going to go up like this. And then this is the reflection in that line, like that. But then on the other half, it gets reflected in this line I'm coming up to now. So now that's a reflection. So that is how we can kind of draw these as accurately as possible. And then we can continue that for the rest of the graph. Now, I'll try to do it quickly. I'm not as good as sometimes when I'm drawing fast. So, oh, there we go. And there we go. So see what we got done there? We got 3 full rotations into 1. And then once you draw it, if you want to, for yourself, you can kind of use a pencil, draw it in just very lightly like that. And then you can get rid of them afterwards. And there we go. This is the end of the video. If you have any questions about this, do not hesitate to get in touch. I hope you have a great rest of your day. Take care.